So what is Laplace transform? Let, let's consider one function fx. Then if we want to find the Laplace transform of this one, so how we will find the Laplace of this? So this L denoted for the Laplace. So Laplace of this fx will be defined as capital Fsb, right? Because this x is converted with the s with the kernel e to the power minus sx. Okay, so we integrate from 0 to infinity with the kernel e to the power minus sx, fx, and dx. If we solve this integration, we will find the function of s instead of f. So this is the Laplace transform basic definition. If you find uh, if you want to find some Laplace of any function, then you can apply this to find the Laplace transform. Okay, so just revise some properties. So number one is linearity of this Laplace. So what the linearity property says, like if we have some function fx and one function, let's say gx, then if we find the Laplace of function fx plus gx, let's say c1 and c2 is the constant, then how can we find? So it can be find like uh, it can be directly operated on this one. Okay, so just confirm me, are you hearing me or not? Oh, okay, okay, okay. So what you are saying, sorry? uh, yes, yes, the x should be infinite less than 0. So x, maybe you can say x is positive. Uh, yes, s can be any one. Thank you. uh, then Laplace of this function, you can write L. Sorry, you can direct apply Laplace of fx plus c2 Laplace of gx. Okay, this is called linearity of the Laplace transform. So you can write like c1. Let's say Laplace of this is fs plus c2, and let's say Laplace of this gx is gs. Okay, so this is simple linear property. And next is, if we have if we have Laplace of fx is equal to f of x, sorry, f of s, then for any constant a, what is the Laplace transform of e to the power ax fx? Actually, these property is very useful when you are calculating the Laplace transform. Okay, so then if you have this Laplace transform of this fx, then simply you can write the Laplace of this whole function is fx minus a. Sorry, s. Okay, so this is one can use as a formula. And third one is, if you have some Laplace transform of fx in fs, and you want to find the Laplace of any x to power n multiply by fx, then how can you find? Just put minus 1 to the power n d to the power n ds, nth derivative of fs you can take. That will be the Laplace transform of this whole things. Okay, And next thing is, if Laplace transform of fx is defined as fs, and the limit x tends to 0 and x also greater than 0 of fx upon x exists, it is some finite number, then it is the limit. Okay, so then Laplace of 1 by x fx, you can find this by integrating from s to infinity f of s, sorry, f of t, you can say. And we can exchange the variable s to t, right? Then when you solve the integration, then put the limit, then it again come in the function of s. Okay, so this is the one formula. Next, again, if you want to find the Laplace transform of integration of s to 0 to x, 0 to x of some function f t dt, then 1 by s will be the Laplace transform of this integration. Okay, if the Laplace of fx is defined as a fs, here we the Laplace transform of fx we are considering fs. Okay, so this was four, this was fifth. Okay, sixth thing you have to remember, like if fx is periodic with period omega, and then f of x plus omega will be fx, right? So then the Laplace transform of fx can be defined as 0 to omega. Only in one period we will find e to the power minus sx fx dx. It will be divided by 1 minus e to the power minus the period in multiply by s. Okay, so this is the method to find the Laplace transform of a periodic function. Periodic function is like sin x, cos x. Okay, so let's go to some example. Question 1. We are just considering fx is equal to 1. Then we find to Laplace of 1. Can you find? Yeah. You can, sorry, depletion. Okay, okay. And otherwise you simply just integrate from 0 to infinity e to the power minus uh, fx and dx. Okay, so our fx is 1. Okay, so 0 to infinity e to the power minus sx dx will be the, and you can integrate this uh, and find 1 upon s. Okay, you will integrate, right? Okay, we will go to question 2. Another simple question: if we consider fx is equal to x square, then what is the Laplace of this fx? 2 factorial by s cube. That is right. What? How can you solve? Yeah. So we will go Laplace of fx is equal to integration of 0 to infinity e to the power minus sx into x square dx. Okay, then you can solve it. mm, Differentiating by part. So 0 to infinity, mm, you will find x square upon s e to the power minus sx, okay, minus 2x upon s square e to the power minus sx minus 2 upon s cube e to the power minus sx. Actually, we are doing integrating by part by in two steps. Like first, we have x square e to the power minus square. First, again we will get one integration x e to the power minus sx. Again, we will do this integrating by part. So we will get three in this one. Okay. So um, now you can solve, like, again we have to uh, consider that x is greater than 0. Okay, so for that we will get, we have to limit here x is equal to 0 to some limit x is equal to r. So if limit r tends to infinity, we have to check which terms are have finite limit. So for how can we solve this? This is at x equal to r. So this will be r square upon s e to the power minus sx minus 2r upon s square e to the power xr sr minus 2 upon s cube and e to the power minus s into r. Okay, minus when we are doing 0, x equal to 0, this will be 0, this will be 0, and this will be minus s into 0 1. Yeah, that will be plus. So plus 2 upon s cube. Okay, so if you put this limit r tends to infinity, then this term will be go to 0, and this term will go to the 0. No, this will not go 0. Sorry, these are minus, sorry. So all these terms will go to the 0, then only this 2 upon s cube will remain. Okay, all terms will go to the 0. So this will be the Laplace of fx with the condition when uh, yeah, s greater than 0. Okay, so for the small function like x square x to the power n, you can remember that this will be the Laplace of n factorial upon s cube x and 12. Okay, so actually these are some basic function. You have to first find from the uh, definition, then you have to remember. You do not need to solve the every time in the question. Whenever you got this function, you can just put the Laplace transform is of this function is this, and another basic function is e to the power ax. Okay, so how? Yes, yes. You can take in the time but we are just it is just variable. Uh, yeah, yeah, yes. So this will be 0 to infinity e to the power minus sx e, e to the power ax, which is this function, this is our fx and dx. Okay. So again we will find limit r tends to infinity, 0 to r e to the power a minus s x dx. Okay. So we will find it limit r tends to infinity. Integration of this will be e to the power a minus s x upon a minus s and 0 to r. So it will be limit r tends to e to the power a minus s r upon a minus s minus 1 upon a minus s. Okay. So you can write this limit r tends to infinity. This will be e to the power minus s minus a into r, and this will be minus s minus a minus, this will be plus 1 upon s minus a. We will just convert for the, now if you put this r is equal to infinity in this one, this term will go to 0 and only this term will left. So we can say 1 upon s minus a with the condition s greater than a. Okay, so this condition is important because otherwise we cannot solve this integration, because this r at r is equal to infinity, this term will go to infinite. Okay. Any question till now? Mm, Next, if you have some function in your mind, you can tell. We can calculate the Laplace transform. Otherwise, I have one more question. Let's fx is equal to e to the power x and 3 for x less than greater than 2 and x greater than 2. So we have to find the Laplace transform of these two. So again we will start from the definition. Laplace transform of fx equal to 0 to infinity e to the power minus s x of fx into dx. Okay. So now our function is in two step, when x is less than 2 and when x is greater than. So we will break this limit into two from 0 to 2 plus 0 to 2 and 2 to infinite. Okay. So from 0 to 2 we will put e to the power f. So f of x uh, e to the power minus sx into e to the power x dx, and here we will put e to the power minus sx into 3 into dx. So this is correspond to fx is equal to 1, and this is correspond to fx is equal to e to the power x. So for this you can write Laplace transform of e to the power x plus Laplace transform of 3. Okay. or you can write 3. We will take the common and Laplace transform of 1. So we just now we put we solve this Laplace transform e to the power ax. Okay, so for this will be s minus 1 because a is 1 here, plus 3. Okay, yeah. Oh, sorry, you have to go with this definition. First part you can, yes. 0 to 2 e to the power minus s minus 1 dx plus 2 to infinity e to the power minus 3 will be out, minus sx dx. Okay, so just try e to the power minus s minus 1f upon s minus 1, and this is 0 to 2 plus 3 e to the power minus sx upon minus l. This will be 2 to infinity. So here we will get e to the power minus 2 s minus 1 upon minus s minus 1, minus, if you put 0 then it will be plus 1 upon s minus 1 plus 3, and if you will put infinity here it will be 0, then minus 1 upon s, sorry, e to the power minus 2 s upon s, this minus, and this limit minus will be plus. So here you will get 1 plus e to the power 2 1 minus s upon 1 minus s plus 1 upon, sorry, 3 e to the power minus 2s upon s. So this will be the Laplace transform of fx, which defined in the two limits x less than 2 and x greater than 2 in two region, the different one. Okay, so you have any question? Next question. We just want to the state function, like one function is minus 1 to add some x equal to 4, and then it is like this is 1 and minus 1. So if you want to find the Laplace of this function, then how it looks like. So first we define this fx will be minus 1 for x less than 0, sorry, for x less than greater than 0, let's say 0, it is coming from infinite. Okay, and 1 for x greater than 4. Okay, then how we will find? So just from the definition, fx equal to integration 0 to infinity e to the power minus sx fx dx. Okay, so you can break the limit 0 to 4 e to the power minus sx, and this will be minus 1 dx plus 4 to infinite and e to the power minus sx 1 dx. Okay, just solve this integration e to the power minus sx upon minus s 0 to 4, and this minus come out. Okay, plus uh, e to the power minus x upon minus s, and this limit will go to the 4 to infinity. So this will be 1 upon s, and it will be e to the power minus 4 s minus, if it will be 0 then it will be 1. Okay, plus if it will be infinite it will be 0, and then 4, then you put minus 4 s upon minus s, this will be plus. Okay, so 1 by s 2 e to the power minus 4s minus 1. Okay, and again we will put the condition as greater than 0. Okay, so next question. Now we will come to some combined of the function, like we have some fx is equal to 5 sine 3x minus 17 e to the power minus 2x. Okay, so how you will find the Laplace of this fx? Laplace of this fx, first we apply the linearity of Laplace transform. You can just write 5 Laplace of sine 3x minus 17 Laplace of e to the power minus 2x. Okay, so sine 3a, you should remember that the Laplace of sine ax is equal to uh, not a upon h square plus a square. Okay, and for in the case of cos ax, you can write it 1 upon h square plus a square. Okay, so we apply this formula in directly. 5 multiply by uh, our here our a is 3, so 3 upon h square plus 3 square minus 17 Laplace of e to the power minus ax. So just now we calculate for e to the power ax. Okay, so from that you can write 1 upon s plus 2. Okay, because there is a and here is minus 2, so you if you put s minus minus 2, it will come as plus 2. So you will find 5 15 upon s square plus 9 minus 17 upon s plus 2. So this will be the Laplace transform of this function. Okay, what next? Just change the type of question. We have one fx is equal to 2x square minus 3x plus 4. Then how you will find? This will be very easy, like Laplace of x square plus, sorry, minus 3 Laplace of x plus 4. So this will be the Laplace of fx. Okay, just now we calculate for x square. same we will put x, and here this 4 multiply by 1, so you can write this Laplace of 1. So for 2 you can write, and for x square this will be 2 upon s cube minus 3 upon s square plus 4 upon s. Okay, let's say we will multiply up two function like Laplace of x e to the power 4x. So we know the Laplace of this one, we know the Laplace of this one, but we don't know any property related to multiply of these two function. Okay, so how will you solve? Any idea? Yes, yes, yes. So one way you can consider this fx for this one, and then apply the property Laplace of x of fx. Okay, and if you, let's say if you consider the function of x is for this one, then you again know that e to the power ax fx of Laplace of something, right? So you can do it in the both way. So let's consider for fx is equal to e to the, what you want to consider, this is fx or this is fx. Yeah, you can, yeah, you can do it in two ways. Yeah, just just I want to know, in the, in first method we are considering fx is equal to x. Okay, so the Laplace of fx is equal to Laplace of x, it will be 1 upon s. Okay, so if fx is this one, then Laplace of e to the power ax of fx, it is fs minus a. Okay, that is the formula, right? So here fx is x, and this will be our fs, f of s. Okay, oh sorry. Okay, so this is our fs. If we have consider fx is equal to x, then Laplace of this e to the power ax into x is equal to, we will put s minus a in instead of s. So 1 upon s minus a will be the Laplace transform of this one. Okay, if you consider fx is equal to e to the power uh, 4x, right? Actually we have a at is equal to 4, so s minus 4 it will be here. Okay, so if we consider fx is equal to e to the power 4x, then our fs will be the Laplace transform of e to the 4s, so it will be uh, 1 upon, So sorry, one mistake we have done. Laplace of this x is s square, so it will be s minus 4. Okay, so for this one, what is the s minus 4 will be the Laplace transform of e to the power 4x. Now if we consider the Laplace of x into the function of x, it is the d over dx function of, sorry, d over ds function of fs. Okay, so we will do Laplace of x e to the power 4x is equal to d over ds, and our fs is 1 upon s minus 4. Okay, so it will be minus 1 upon s minus 4 whole square. Okay, formula is minus 1 to the power n, n था ना, तो n की जगह पे 1 आ गया, तो माइनस 1 यहाँ रह जाएगा, तो माइनस यहाँ से प्लस हो जाएगा. Okay, these type of question we have to repeat. Next question, let's say Laplace of, we have to find e to the power minus x, x cos 2x. Can you find this? X into cos 2x. Do you remember the Laplace transform of x cos 2x? Yeah, yeah. Back to back two formula we have to use. So we have consider fx is equal to cos 2x, then Laplace of this fx. What else here? Puja Chandan. So Puja, you remember this? Fx is equal to cos x, then what is the Laplace of this cos 2x? Okay, okay. I just want, yeah, just we repeat like Laplace of cos x equal to cos ax is equal to 1 upon s square plus a square. For sin x ax it is a upon s square plus a square. Okay, so for cos x it is 1 upon s square plus 4. Okay, 2 k square will be 4. So then Laplace transform with x into fx. Sorry. Okay. In numerator it, yeah, okay. Okay, okay. So x into fx. So it will be minus d over d s s upon s square plus 4. Now you have to differentiate it. You will differentiate s square plus 4. This will be the same differentiation of this one plus, am I writing right? Or it will be minus. Again, this will be same, and differentiation of 2s. So it will be x square plus 2s square will be from here plus 4 upon s square plus equal to 3s square plus 4 upon s square plus 4. Now if you put Laplace of e to the power minus x and x and fx. It will be f s plus 1. Okay, so it will be 3 s plus 1 का whole square plus 4 s plus 1 whole square plus 4. So this will be our final answer. You can solve further. Let's again come to one question. Laplace of sine 3x upon x. In this one we will use the last identity. So this will be our fx. So Laplace of sine 3x, this will be 3 upon s square plus 9. Okay, again the formula I will repeat. Ax is equal to a upon s square plus a square. Okay, so this Laplace of sine 3x upon x, it will be, we integrate from s to infinity and we just put t in instead of this s. So 3 upon t square plus 9 integration dt. So this we will put limit r tends to infinity. This integration will as to r 3 upon t square plus 9 dt. So the integration of this one uh, t square plus a square. So this will be tan inverse t upon 3. Okay, as up to r. So this, so this limit tends to r tends to infinity. So 3 limit r tends to infinity tan inverse r by 3 minus tan inverse s by 3. So if r tends to infinity, the tan inverse infinity is equal to pi by 2. Okay, so 3 uh, pi by 2 minus tan inverse s by 3. Okay, this will be the answer. Laplace transform. Yeah, yes, yes. Okay, what else? So let's come to one question related to periodic function, right? Or you want to do some integration of Laplace of some integration. Okay, we can do both, right? 10-minute more. So Laplace transform of integration 0 to x sine hyperbolic 2t dt. Can you think about this question? Yeah, right. Then, okay, sine hyperbolic 2t means what? Okay, that's one is the form of this sine hyperbolic 2t. E to the power minus 2t plus uh, minus 2t upon by 2 or 2i. Okay, okay. So this Laplace transform sine hyperbolic 2t, it will be Laplace transform of e to the power 2t minus e to the power minus 2t, and 1 by 2 we are taking out. Then this Laplace of e to the power 2t minus Laplace of e to the power minus 2t. So here we can 1 upon s minus 2 minus 1 upon s plus 2. So it will be 1 upon 2 s square minus 4 s plus 2 minus s plus 2. It will be 1 by 2, 4 to cancel. So it will be 2 upon s square minus 4, 4 not 4 square. Okay. So now we are applying the that property Laplace of integration 0 to x sine hyperbolic 2t dt. So this will be what 1 upon s 2 upon s square minus 4. Okay, how it can be written? Yeah, in this one, this property I am using. Okay, okay. The last question. Just prove f of x plus omega is equal to fx if then Laplace of f equal to 0 to omega e to the power minus sx f of x dx upon 1 plus e to the power minus omega s. Can you prove this? Okay, like we have this periodic function x plus omega is equal to fx. Okay, Then what will be fx plus 2 omega? This will be like fx plus omega plus omega. Okay. So this will be not fx because this omega is idiot. This minus sign will come. Minus x plus omega. No, I am just taking. See, omega is the given here, but what happens when we are adding 2 omega? Two times when we are adding, then some minus term will come. Hmm? Sorry, sorry. This uh, this will be minus and uh, let's, yes, 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 yes. I am just confused. Sorry. So okay, just we start from the. We have to prove this. We are not using this for now. So fx will be we integrate in 2 omega e to the power minus sx. So we are right, wrong question. They are saying that prove fx plus omega is equal to minus fx. Then the Laplace transform p 0 to omega e to the power minus sx fx dx upon 1 plus e to the power minus omega s. Sorry, I missed this minus. So so we have f of x plus. We are just seeing what happens at 2 omega. Okay, so this will be f x plus omega. So this will be minus fx. Okay, sorry. This is we are considering like capital X. Then capital X plus omega is equal to minus fx plus omega. Okay. Now again, if you put minus, then it will be again minus fx. So this will be plus fx. Okay. Now this is the periodic function fx plus 2 omega is equal to fx. So the period is 2 omega, not the omega. Okay. So now we have when we are saying Laplace of fx. So for the periodic function, we have to integrate in the period. Okay. So we are integrating 0 to 2 omega, not omega, e to the power minus sx fx dx upon 1 minus e to the power minus 2 omega s. This was our formula for the periodic function. Okay. So now if we are breaking this 0 to omega plus omega to 2 omega. Okay. So 0 to omega e to the power minus sx f of x dx upon 1 minus 2 to the power minus 2 omega s, and here you can write omega 2 omega e to the power minus sx fx dx. Okay. Now we will substitute because we have to. solve this term because there is also only we have to come till 0 to omega. Okay, so now we will substitute y equal to x minus omega in the second integral one. Then what happens? Uh, y equal to x minus omega. So this is omega upon 2 to omega e to the power minus here is x f of x. Here you can write 0 to omega e to the power minus s x की जगह पे हो जाएगा बाई प्लस ओमेगा f of y plus omega and dy. Is it okay? See, if you change the limit, then the we want to make this limit from 0 to omega because in the proof there is only limit 0 to omega. Okay, we have to prove this one. This yes. Then only if like it is odd function in some period, then this sign replace only plus and our formula is minus. Okay, so that we want to prove. Yes, then we can add in we put it there and add in this same integration. Okay, so if you want to this minus s and omega and this is s omega, so this minus s omega will come out e to the power minus s omega because this integration is correspond to dy. So this will be constant, so 0 to omega and e to the power minus s by uh, f of y plus omega is minus 5 pi minus fi, right? And dy. So it will be minus e to the power minus s omega integration 0 to omega e to the power minus sy and f of y dy. Now you can change y to x directly, right? This is just the transformation of variable transform. So that integration will be equal to minus e to the power minus omega s 0 to omega e to the power minus sx f of x dx. Okay, so Laplace of that fx with the condition f of x plus omega equal to minus fx, you can write in first see in this integration and this integration is same, only the in the instead of this integration when we put this integration this factor is extra, right? And this is plus sign, so we can take this whole integration common and it will be 1 minus e to the power minus omega s integration of 0 to omega e to the power minus sx f of x dx. Okay, upon 1 minus e to the power minus 2 omega s. In the formula it is 2 omega s. Okay, so here you can put 1 chi square. It is 1 chi square. Okay, so you can write 0 to omega e to the power minus sx fx ds 1 minus e to the power minus omega s upon, you can write 1 minus e to the power minus omega s and 1 plus e to the power omega s. So it will be cancelled out, and you can put e to the power minus sx fx dx upon 1 plus e to the power minus omega s. Okay. More question? Okay, we will come with more question next week on the Laplace transform with some Fourier transform also, because in the next week I think one lecture of Fourier transform will be also there, right? Okay, same day means this live session. Yeah, this live session I cannot change. This is decided by this NPTL only. We cannot change. Thank you, Hari.